In the maintenance bay at Rabaul Naval Air Base, on the morning of March 14, 1943, Petty Officer 2nd Class Kenji Matsumoto committed an act of sabotage so subtle that it would be classified as innovation. He poured precisely measured quantities of a benzene alcohol mixture into the fuel tanks of a Mitsubishi A6M0, a mixture that had been explicitly forbidden by Naval Aviation Command, a mixture that violated every technical specification that the Imperial Japanese Navy had established for aircraft fuel. Matsumoto was not a pilot. He was a mechanic, 41 years old, with 19 years of service in naval aviation. He had maintained engines through the entire Pacific War, watching them deteriorate, watching their performance degrade with each passing month as fuel quality declined, watching pilots struggle to coax sufficient power from engines that were being starved of proper fuel specifications. He had watched good pilots die because their aircraft could not achieve the performance they needed. The Zero that sat before him that morning was scheduled for a test flight. The pilot was Lieutenant Isamu Takahashi, a veteran with 32 confirmed kills, a man whose skill was undeniable, but who had recently complained that his aircraft seemed sluggish, unable to reach the velocities he knew the machine was theoretically capable of achieving. Matsumoto had investigated, as he did with every aircraft that showed performance degradation, and had reached a conclusion that terrified him. The fuel being supplied to Rabaul was contaminated. Not accidentally, the contamination was systematic, the result of degraded refining capacity at Japanese petroleum facilities. The Japanese military had established strict fuel specifications for aircraft engines. High-octane fuel, refined to precise standards, was essential for optimal engine performance. But as the war had progressed, Japanese refining capacity had become increasingly compromised by American bombing campaigns and by the loss of oil fields in Southeast Asia. The fuel that was reaching Rabaul was often of significantly lower octane rating than specifications required. Pilots flew aircraft that their engines were not properly matched to, resulting in reduced power output, reduced maneuverability, reduced speed. Matsumoto understood the physics intimately. He had studied engine design as a young man before the war, in technical school in Kobe. The internal combustion engine was a compromise between competing demands: compression ratio, fuel octane rating, ignition timing, air-fuel mixture, cooling capacity. Change one variable, and all others required adjustment. The forbidden fuel mixture that Matsumoto had developed was a compensation mechanism. Benzene, when added to low-octane petroleum fuel in precise ratios, increased the effective octane rating. The benzene burned hotter, burned faster, released energy more efficiently. The mixture had been discovered informally by mechanics across the Pacific, but it had been forbidden by Naval Command because it violated the technical specifications and because it introduced complications. The benzene burned hot enough to potentially damage engine components if not properly managed. Matsumoto had tested the mixture on a ground engine, monitoring temperature and pressure. He had calculated the ratios with precision, reducing the benzene concentration below what other mechanics were using, attempting to maximize performance while minimizing the risk of engine damage. At 0830 hours, Lieutenant Takahashi climbed into the cockpit of the Zero. He did not know that the fuel in his tanks was mixed with benzene. The flight plan was a standard performance evaluation: climb to altitude, sustain maximum velocity at different altitudes, perform standard maneuvers, return to base. It was a routine test that had been conducted hundreds of times. The engine started with its familiar growl. Takahashi taxied to the runway, performed his pre-flight checks, and accelerated down the tarmac. The Zero lifted into the air above Rabaul, the island falling away beneath him, and the ocean stretching toward the horizon. At altitude, Takahashi pushed the throttle to maximum power. The engine responded with an intensity he had not experienced in months. The acceleration was profound. The aircraft climbing, the airspeed increasing beyond what his instruments indicated was standard for the Zero at this altitude and power setting. He checked the gauges repeatedly. Temperature was rising, but within acceptable parameters. Fuel consumption was elevated, but not catastrophic. Power output was significantly above normal. For the next 45 minutes, Takahashi flew the Zero with an exhilaration he had almost forgotten. He pushed the aircraft to velocities that approached, or possibly exceeded, the theoretical maximum velocity that Zero pilots had long accepted as unreachable. He performed aggressive maneuvers, diving and climbing, testing the aircraft's responsiveness. Everything was working at an intensity that seemed impossible. When he returned to Rabaul and landed, Takahashi taxied directly to the maintenance bay. He found Matsumoto waiting, with careful neutrality on his face. "The aircraft is performing anomalously," Takahashi said without preamble. "I want to know why." "The pilot is skilled," Matsumoto replied carefully. "Perhaps the aircraft responds to skilled operation." "Do not lie to me, Matsumoto. Something has changed." "The fuel." Matsumoto hesitated for precisely 2 seconds, the interval between order and conscience. "Yes, sir. The fuel has been modified. Benzene addition, in precise ratios. The standard fuel supplied to this base is inadequate. The octane rating is insufficient for optimal engine performance. The benzene compensates." Takahashi's expression transformed. From curiosity to understanding to recognition of the contradiction he had just encountered. His aircraft performed beyond specification, which meant it had been modified in violation of orders. But the modification had improved performance in a way that seemed nearly impossible to achieve through standard engineering. "How many aircraft have you modified?" Takahashi asked. "This is the first," Matsumoto said. "I wanted to verify that the mixture was viable before..." "Before what? Before disobeying direct orders? Before accepting that our pilots would continue to die because our aircraft cannot achieve the performance they require." Takahashi stood in silence. Around him, the maintenance bay continued its routines. Mechanics working on engine components, orderlies moving between stations, the ambient sounds of military aviation continuing regardless of this small moment of moral clarity. "You will conduct no further experiments," Takahashi said finally. "I am ordering you directly, no further modifications to any aircraft. If Naval Command discovers that a Zero has been operated with unauthorized fuel mixture, there will be consequences. Not for me, Matsumoto, for you." But 3 hours later, Takahashi submitted a report to the commander of Rabaul Naval Air Base. The report recommended investigation into fuel quality standards. It included measurements of the standard fuel's octane rating compared to specification. It noted that performance degradation across the Zero fighter force correlated with declining fuel quality. It concluded with a careful phrase, "It is possible that fuel specifications require review in light of current supply constraints." The report was forwarded up the chain of command. It reached the Naval Air Technical Bureau in Tokyo. It was examined by engineers who understood the problem Takahashi had identified, the systematic degradation of fuel quality, but who were constrained by command decisions that had been made at levels above their authority. By May 1943, a directive came down from Tokyo. A modified fuel specification was authorized for field use. The specification included provisions for benzene addition in carefully controlled ratios, designed to compensate for degraded petroleum fuel quality. Mechanics across the Pacific received the new specifications. Matsumoto's unauthorized experiment had become official policy, but Matsumoto never received formal credit for the discovery. The fuel modification was attributed to the Naval Air Technical Bureau's research efforts. His name appeared nowhere in the documentation. He remained a petty officer, a mechanic, a man whose insight had changed naval aviation policy through a single act of unauthorized experimentation. In the months that followed, Zero aircraft operating with the modified fuel mixture demonstrated performance characteristics that had seemed impossible just months earlier. Pilots reported improved acceleration, higher velocity, better climb performance. The aircraft that had been designed nearly a decade earlier suddenly seemed to have been given new life. But the improvement came at a cost that would not become apparent until it was too late. Now I invite you to leave in the comments where you're watching from and the exact time you're listening to this story. We're interested in knowing how far these documented accounts travel and at what moments of the day or night they reach you. By July 1943, 3 months after the modified fuel specification had been authorized, the consequences of the benzene-enhanced fuel were becoming apparent to mechanics across the Pacific. Engines that had been operating with the mixture were showing signs of accelerated wear. Piston rings were failing prematurely. Valve seats were corroding. In some cases, engines were seizing completely after relatively brief operational periods. Matsumoto, now aware that his unauthorized experiment had become official policy, requested permission to investigate the engine degradation. He was assigned to conduct a technical analysis of 12 Zero engines that had been removed from aircraft due to mechanical failure. The analysis revealed a pattern. Engines that had operated with benzene-enhanced fuel showed degradation rates that were 3 to 4 times higher than engines operating on standard fuel. The benzene burned hotter than conventional fuel. It burned faster. It released energy more efficiently, but it also imposed stresses on engine components that were not designed to withstand the elevated temperatures and pressures. Over time, those stresses accumulated. Metal fatigued, seals degraded, components failed. Matsumoto prepared a technical report documenting his findings. The report was cautiously worded. It did not openly criticize the policy that had been authorized in Tokyo, but it clearly identified the accelerated wear pattern and suggested that operational limitations might be necessary. Maximum power operations using the benzene-enhanced fuel should be limited to specific circumstances, Matsumoto recommended. Sustained maximum power flight should be avoided. The report was submitted to the base commander at Rabaul. It was forwarded to higher authority. By September 1943, a revised directive came from Tokyo. The benzene-enhanced fuel could continue to be used, but with operational restrictions. Maximum power operations should be limited to combat engagements or emergency situations. Standard power cruise operations should utilize the less demanding standard fuel mixture. But the directive was vague on implementation. How would pilots know when they could use maximum power? How would mechanics enforce the restrictions? The result was predictable. Pilots used the enhanced fuel and maximum power settings whenever they felt it was justified. Mechanics maintained aircraft according to whatever fuel was available, often without clear knowledge of what mixture had been used or what restrictions applied. By October 1943, Zero engines across the Pacific were failing at accelerating rates. The aerial superiority that Japan had maintained through superior aircraft design was being undermined by mechanical reliability that was deteriorating beneath the demands being placed on the engines. Lieutenant Takahashi, the pilot who had first tested Matsumoto's unauthorized mixture, was assigned to a forward airfield on New Guinea in October 1943. He was leading a squadron of 8 Zero aircraft on a patrol mission when his engine failed at altitude. The cause of the failure would never be definitively established. Engine seizure due to mechanical degradation was the conclusion, but the result was certain. Takahashi's Zero descended uncontrollably into the jungle below. No wreckage was ever found. No body was ever recovered. Matsumoto learned of Takahashi's death 3 weeks after it occurred, through a brief notice that appeared in base communications. The notice did not mention that Takahashi's engine had failed due to accelerated wear from benzene-enhanced fuel use. It simply recorded the loss: Lieutenant Isamu Takahashi, missing in action, presumed deceased October 17, 1943. In the maintenance bay at Rabaul, Matsumoto continued his work. He serviced engines, maintained aircraft, supervised younger mechanics. He did not speak about Takahashi, did not make public connection between the pilot's death and the fuel mixture he had developed. But the weight of it accumulated silently, the knowledge that his attempt to improve aircraft performance had contributed to the death of at least one pilot, and likely many others. By late 1943, Japanese military production was in crisis. Aircraft losses were exceeding production capacity. Pilot losses were exceeding training capacity. The air superiority that had characterized the first 2 years of the war was being systematically dismantled by Allied production, Allied pilot training, and the cumulative effects of American aircraft design that was proving superior across a range of operational metrics. The benzene-enhanced fuel had provided a temporary performance advantage, but at a cost that was becoming increasingly apparent. Accelerated engine degradation meant that aircraft that had been serviceable for hundreds of hours of operation were now reaching service life limits in half that time. The fuel mixture had solved one problem, insufficient power, while creating a more fundamental problem, mechanical reliability. In November 1943, Matsumoto requested a transfer. He asked to be reassigned to a maintenance facility in Japan, away from the frontline combat operations, away from the constant attrition of pilots and aircraft. His request was approved. In December 1943, he departed Rabaul aboard a transport vessel bound for Japan. The voyage took 3 weeks. The transport ship, traveling at night through waters watched by American submarines, finally reached a port near Kobe, the city where Matsumoto had grown up, where he had attended technical school, where his wife and teenage children were waiting. For the first time in 4 years, Matsumoto walked on Japanese soil as something other than a soldier in transit. He reported to a maintenance facility that supplied aircraft engines to assembly plants throughout western Japan. The facility was already showing the effects of American bombing: workshop damage that had been partially repaired, material shortages, worker fatigue. Matsumoto was assigned to work on engine inspection and certification. His role was to examine engines that had completed assembly and determine whether they met specifications before they were installed in aircraft. It was technically precise work, important work, but it was work divorced from the immediate consequences of combat. He was not watching pilots fly aircraft into battle. He was not receiving casualty reports, but in the technical data that was forwarded to the facility, he could read the larger trajectory. Aircraft production statistics showed that the serviceability rates of 0 aircraft were declining. Aircraft that reached the front lines were spending increasing amounts of time in maintenance depots. The attrition rate, not from combat, but from mechanical failure, was increasing. By early 1944, Matsumoto had assembled the technical evidence. The benzene-enhanced fuel modification that had been intended to improve aircraft performance was contributing to a systematic degradation of aircraft reliability. The engines were failing faster. The aircraft were becoming less available. The pilots who flew them were being placed in increasingly unreliable machines. Matsumoto prepared a comprehensive technical report. He documented the correlation between benzene fuel use and accelerated engine wear. He calculated that the modification, rather than improving overall combat effectiveness, was actually reducing it by degrading reliability faster than performance was being improved. He recommended that the fuel mixture be discontinued, that engines be redesigned to accommodate higher octane fuel requirements, and that effort be focused on improving fuel refining capacity. The report was submitted through formal channels. It was reviewed by the Naval Air Technical Bureau in Tokyo. It was analyzed, discussed, and then filed away. No action was taken. The fuel mixture continued to be used. The engines continued to degrade. The pilots continued to lose aircraft to mechanical failure. By mid-1944, the Pacific War had reached a point of inevitable conclusion, though military leadership in Tokyo refused to acknowledge it. American forces had fought their way across the Pacific, island by island, establishing air superiority over each contested territory before moving on to the next objective. Japanese aircraft, including the Zero, with its increasingly unreliable engines, were being outmatched not by superior individual aircraft design, but by superior numbers, superior pilot training, and superior logistical capacity. The benzene-enhanced fuel was now a standard feature of Japanese military aviation, but its use had been restricted through operational doctrine rather than through technological improvement. Pilots were supposed to use standard fuel for cruise and maneuvering, and were supposed to reserve the enhanced fuel for combat engagement. But in the chaos of combat operations and the degradation of supply lines, these distinctions became increasingly blurred. Matsumoto had been assigned to a new facility in Nagoya, where aircraft engines were being produced for a next-generation fighter that the military hoped would regain air superiority. The new aircraft, designated the Ki-84 Hayate, was being designed to incorporate lessons learned from years of Pacific War combat. It was faster, more heavily armed, more maneuverable than the Zero, and it required engines that could operate at higher power levels with greater reliability than existing designs could provide. In the engine design facility, Matsumoto worked alongside engineers who were attempting to create power plants that could withstand the stresses of the new aircraft. They were aware of the accelerated wear problems caused by benzene-enhanced fuel, but they were constrained by a fundamental reality. There was no fuel being supplied that met the original specifications for Zero engines. The standard fuel was degraded. The benzene-enhanced fuel was what was available. The engineers had to design engines that could survive operation with inadequate fuel. It was a problem with no solution. Design an engine to operate with fuel that was fundamentally unsuitable for that engine's design parameters. The engineers tried. They increased cooling capacity. They modified fuel injection patterns. They adjusted compression ratios. They experimented with different alloys for critical components. None of these modifications solved the fundamental problem. The fuel was wrong for the engines, and no engine design could compensate for that fundamental mismatch. In August 1944, American bombing raids on Nagoya began in earnest. The aircraft manufacturing facilities that had been the heart of Japanese aviation production were now primary targets for American B-29 Superfortress bombers. Matsumoto's engine design facilities suffered serious damage in a raid on August 10th. The main assembly hall was destroyed. Technical files were lost. Several engineers were killed. Matsumoto survived, sheltering in a reinforced basement. When he emerged, the facility was largely destroyed. The engine design work that had occupied him was now impossible to continue in the damaged facility. He was reassigned, transferred to a dispersed manufacturing facility in the countryside, outside the city, away from air raid targets. The dispersed facility was primitive compared to the advanced factory in Nagoya. It was a converted agricultural facility with minimal equipment, minimal infrastructure, minimal capacity. Its purpose was to continue engine production using whatever materials and equipment could be salvaged or relocated from the city facilities. It was at this facility, in September 1944, that Matsumoto made a decision that would occupy the remainder of his life. He began to systematically document the technical history of the benzene-enhanced fuel modification. He compiled every piece of technical data he had accumulated: engine test results, wear analysis, failure modes, comparative performance data. He wrote detailed explanations of the modification, its reasoning, its consequences. He included calculations showing that the modification had actually reduced overall combat effectiveness, despite improving individual aircraft performance. The documentation was meticulous, precise, and utterly damning. It demonstrated that a decision made with reasonable intentions, improving aircraft performance to match degraded fuel quality, had contributed to a systematic decline in military aviation effectiveness through accelerated mechanical degradation. Matsumoto bound the documentation in a waterproof canvas package. He wrote on the cover, in careful characters, "Technical History of Fuel Modification Implementation, Imperial Japanese Naval Aviation, September 1944. He gave the package to his wife with instructions. "If I do not survive this war, preserve this. After the war ends, ensure that these documents are provided to the technical authority that investigates Japanese aviation systems. These records show what happened and why it happened. Someone should know." If this story surprised you, make sure to leave a like to support the channel. In January 1945, American forces occupied facilities in the Philippines that contained substantial archives of Japanese military aviation documentation. Among these documents were technical specifications, maintenance records, and operational histories of the Zero aircraft and other Japanese fighters. American military intelligence and technical specialists began the massive undertaking of translating, analyzing, and cataloging this material. Major Frank Holloway, an aeronautical engineer assigned to the Foreign Technical Intelligence Division, was tasked with analyzing Japanese aircraft engine development. He reviewed hundreds of documents: engine specifications, performance test results, maintenance data, failure analysis reports. He was attempting to understand how Japanese military aviation had evolved throughout the war, what engineering decisions had been made, what had succeeded, and what had failed. In February 1945, Holloway discovered references to a fuel modification that had been implemented across Japanese aviation units. The references were scattered through various documents, operational directives, maintenance procedures, technical bulletins. By itself, each reference was minor. But assembled together, they revealed a systematic change in aviation fuel specifications that had been introduced in mid-1943. Holloway began to search for documentation that explained the reasoning behind the modification. He found scattered references to fuel quality degradation, to performance requirements, to engineering constraints, but he found no comprehensive explanation. No single document that laid out why the modification had been made, what its consequences had been, what the technical analysis of its effects indicated. It was a gap in the documentary record that troubled him. In his experience, major modifications to military aviation systems were carefully documented. The rationale, the analysis, the consequences, the recommendations for future action. But in this case, the benzene fuel modification appeared to have been implemented, used extensively, and then simply continued as standard practice with little formal analysis of its effects. In May 1945, as German forces surrendered and American attention shifted entirely toward the final months of the Pacific War, Holloway submitted a technical assessment of Japanese aircraft engine development. His assessment included a section on the fuel modification. It appeared to be a pragmatic response to fuel quality degradation, implemented at field level and subsequently authorized by higher command. It had provided short-term performance improvements, but Holloway estimated that it had contributed to accelerated engine wear that reduced overall aircraft reliability. The assessment was filed away. By then, the war was nearly over. Japan surrendered in August 1945. The technical analysis of Japanese aviation systems became a matter of historical curiosity rather than operational urgency. But in the months following the Japanese surrender, American technical teams were deployed to Japanese military facilities to recover equipment, documentation, and expertise. It was during this phase that American personnel encountered Kenji Matsumoto. Matsumoto had survived the war. He had been stationed at the dispersed manufacturing facility in the countryside when the war ended. He had not been killed in air raids, had not been conscripted into military action, had endured the war in technical obscurity. When Japanese military facilities were being examined by American occupying forces, Matsumoto was identified as a senior engine specialist and was asked to provide technical briefings on Japanese aviation engine development. During one of these interviews, in September 1945, Matsumoto revealed the existence of the documentation package that he had prepared and given to his wife for preservation. He explained its contents, its purpose. An American technical officer named Captain Richard Morrison recognized the significance of what Matsumoto was describing, a comprehensive technical history of a major aircraft modification, written by someone who had been directly involved in both its implementation and its analysis. The documentation package was retrieved from Matsumoto's home. It was translated from Japanese into English. It was analyzed by American technical specialists. By October 1945, the complete technical history of the benzene fuel modification was in American hands, documented by the very man who had developed it, analyzed by the man who had lived through its implementation and consequences. Major Holloway was brought in to review the translated documentation. He read Matsumoto's detailed technical analysis, the engine test data, the wear analysis, the calculation of performance versus reliability trade-offs, the conclusion that the modification had actually reduced overall combat effectiveness. Holloway's assessment shifted when confronted with this evidence. In his October 1945 report, he concluded, "The benzene fuel modification, though tactically sound in addressing immediate performance degradation from fuel quality issues, created accelerated mechanical wear that systematically reduced aircraft availability and reliability. The modification appears to have been implemented at field level by Petty Officer Kenji Matsumoto, subsequently authorized by Naval Command without complete technical analysis of long-term consequences. The documentation preserved by Matsumoto provides the most complete technical analysis of this modification available." For the first time, Matsumoto's name appeared in official American technical assessment, identified as the originator of the modification, credited with having analyzed its consequences, acknowledged as having preserved the documentation that explained what had happened. But the American assessment remained classified. It was filed in the Foreign Technical Intelligence Division archives. Only a handful of military scientists and engineers ever read it. The general history of Japanese aviation development that emerged in post-war analysis attributed the fuel modification to the Naval Air Technical Bureau's engineering efforts, to systematic research programs, to institutional decision-making. Matsumoto's individual contribution remained unknown, mentioned only in classified technical documents that were locked away for decades. Kenji Matsumoto lived for 32 years after the war. He worked as a civilian consultant for Japanese companies involved in aircraft manufacturing and maintenance. He consulted with engineers designing new engines. He published technical papers on engine design and reliability, but he never publicly discussed the benzene fuel modification. He never revealed his role in its development. He lived quietly, professionally, maintaining the discretion that military service had instilled in him. In 1977, at the age of 75, Matsumoto granted an interview to a Japanese technical historian named Dr. Yoshiro Nakamura. The interview was conducted over 3 days, with Nakamura recording Matsumoto's account of his wartime technical work. Matsumoto discussed the fuel modification, his reasoning for developing it, his subsequent analysis of its consequences. The interview became the basis for a technical history that Nakamura published in 1979 in a specialized Japanese-language journal focused on wartime technology. The article was titled "Engine Reliability and Fuel Quality in Imperial Japanese Naval Aviation, a Technical History of the Benzene Modification Program." It included extensive quotations from Matsumoto's interview, his technical analysis, and his assessment of the modification's consequences. The article remained relatively obscure, published in a specialized journal in Japanese, read primarily by technical historians and engineers within Japan. But it established in the historical record Matsumoto's role in the modification's development and analysis. By name, identified as the originator, credited with having understood both the benefits and the consequences of his work. In 1985, Major Frank Holloway, by then retired from military service, published a comprehensive technical history of Japanese aircraft during World War II. The book included a section on engine development that included discussion of the benzene fuel modification. Holloway cited both Matsumoto's wartime documentation and Nakamura's 1979 article, providing a cross-cultural technical history that acknowledged Matsumoto's contributions in both English and Japanese academic records. In 1988, when American military archives were declassified more extensively, Matsumoto's documentation package was made available to researchers. By then, the technical details were of primarily historical interest. The engines were long obsolete. The fuel specifications were no longer relevant, but the documentation became available in archives, accessible to anyone conducting research on the technical history of the Pacific War. Kenji Matsumoto died in 1988 at the age of 86. He died knowing that his wartime work had been documented, analyzed, and preserved in the historical record. He died knowing that his role in developing the benzene fuel modification had been acknowledged. He died knowing that his attempt to improve aircraft performance had been accurately assessed in retrospect as both pragmatic and ultimately counterproductive. In 1995, 50 years after the war's end, a comprehensive technical exhibition was organized in Tokyo, examining Japanese technology during World War II. The exhibition included a section on aircraft engine development. Displayed in this section was a reproduction of Matsumoto's technical documentation, his original analysis of the benzene modification program, translated into English, analyzed in contemporary context. The display included a biographical note. Petty Officer Kenji Matsumoto, 1902-1988, was a naval aviation mechanic whose technical innovation, the benzene enhancement fuel mixture, was implemented across Japanese fighter aircraft from 1943 onward. Matsumoto's subsequent analysis demonstrated that while the modification provided short-term performance improvements, it resulted in accelerated engine degradation that ultimately reduced overall combat effectiveness. His documentation of this technical history is one of the most complete records available of how wartime resource constraints forced engineering compromises with consequences that extended beyond immediate tactical concerns. Today, in the archives of the National Diet Library in Tokyo, in American military technical archives, in university research libraries across the world, Matsumoto's documentation remains available. His name appears in technical histories of Japanese aviation. His engineering insight is cited in studies of how resource constraints force technological compromises. His attempt to solve an impossible problem, how to make inadequate fuel work in engines designed for superior fuel, is remembered as an example of pragmatic engineering under wartime pressure. But the human cost of his solution, the pilots whose engines failed, the aircraft that were lost to mechanical degradation, the lives that were shortened by the performance demands placed on engines that could not sustain them, remains largely unknown. The names of the pilots are lost. The individual aircraft are no longer remembered. The specific moment when an engine failed, when a pilot lost control, when someone died not in combat but in mechanical failure, these moments exist in sparse military records, invisible to history. What remains is Matsumoto's documentation, precise, technical, melancholic in its clarity. It shows a mechanic who understood that his attempt to improve things had created new problems. It shows an engineer who, faced with resource constraints, made pragmatic decisions that had consequences extending far beyond what he could control. It shows a man who, at war's end, chose to document what had happened, to preserve the record, to ensure that someone, someday, would understand not just what had been done, but why it had been done and what its consequences had been. The war ended in 1945, but for Kenji Matsumoto, the responsibility for understanding what had been attempted and what had failed extended throughout the remainder of his life. He carried the weight of his own technical insight, the knowledge that he had been right to see a problem, that his solution had been reasonable, and that the consequences of his solution had extended into dimensions he could not have fully anticipated or controlled. The fuel burned hotter than conventional fuel. The engines wore faster. The pilots flew aircraft that were less reliable than they seemed. And a mechanic, decades after the war, recorded what had happened so that the record would remain, so that the mistake, if it was a mistake, would not be repeated, so that someone would know what one man had tried to do and what it had cost. The aero engines are silent now. The aircraft have been scrapped or preserved in museums. The fuel specifications have been forgotten. But the documentation remains, a technical ghost of a wartime decision made by a man trying to solve an impossible problem with the resources he had available. Subscribe to our channel to explore more cases and curiosities from World War II. Thank you for following the story. See you in the next video.